Well, I messed up now. I had something connected to output S1 and I left it connected, and that should not have happened. And then I was messing on that same cable at the other. Anyway, long story short, I put 12 volts where I shouldn't have. And now I'm going to try and evaluate the problem. I think I know where it is. Okay, so I have it plugged in straight from that probably broken output to receive 1, so I'm going to enable that source, and it's set to, yeah, minus 10 dBm. And it's a bit low, minus 13, high frequencies. That could be just a cable, but that's very odd. Like, why would it dip to minus 30 here? So let's try, so it's a couple different amplitudes, starting at minus 50, which should be the lowest, and I'm gonna just... I went on and did the same test at different amplitudes to see if the output attenuators were working normally, and that dip at 100 megahertz was always present. Now this input is in fact generated by the combination of two power amplifiers. There's a high frequency amp here that's AC coupled, and there is a DC coupled amplifier for the lower frequencies. It's not clear where the crossover happens, so I rigged a very quick simulation to get a rough idea of this, and this is roughly, so the DC amp starts cutting out at, what is this? 300 kilohertz or so. So that really didn't match the dips I was seeing, and I really don't have a better explanation for that dip and why it was at 100 megahertz. I think the module that I need to get to is in the top and probably near this corner, and I'm hoping I don't need to take this box off the shelf, so I'm going to try and take the top cover off. So these two stacked boxes would be the output attenuators, and these are the power amplifiers. Okay, so to disassemble this module, it's interesting. You start with the top lid, which was this one, and then you take 4 small screws and the top lid pops off, like on these. And then you got to take out these studs, which hold that's a channel 2 power amplifier, and this funky 2-sided box shield. Then you can just tilt this over there. And lucky me, the protection diodes are failed short, which means for small amplitudes they... Actually no, I take that back. Yeah, almost a dead short. One of them I'm reading 0, on the other side like 70 ohms or something. So I'm going to move up and see if those the final amplifier transistors are also fine. I'm going to check a couple diodes and this and that, but I think it's probably just the diodes that are clamping, they're severely clamping the output. And the reason I'm still seeing some signal because, well, it's not a perfect short, and there is some feedback, maxing out the gain on this and trying to compensate for the diodes. Okay, fast forward a few days, I replaced those 4 short diodes. I took a chance and put everything back together. I think it's going to work. So I have a power meter that I'm going to be using. And never mind the bouncing traces, it's just trying to measure nothing, but the RF power meter is plugged into source number 1. So if I go all the way at 500 megahertz, yeah, 0 dBm, I'm reading 0.2. I'm just going to do a few spot checks because I think it's fixed. The problems earlier were at 300 kilohertz, which is around here, and it's good still, 0 dBm plus or minus. Like this is not terribly flat, and that's okay. And below about a few kilohertz, this power meter's not really going to work very well. Yeah, 2 kilohertz, but still that's very good. That was 0 dBm. Let's see. I want to test this at its maximum of 15 dBm, but my power sensor is not going to like that, so I have a 20 dB attenuator there. And now let's see, so it's reading minus 20, beautiful, and we go to 10 here, I'm reading yes, that is good, and 15 should be -5. Yeah, very good, very good. How about at high frequencies? Bit more drop, that could be the attenuator. Well, attenuator should be pretty flat. It's still within 2 dB. Mind you, 15 dBm, I'm expecting some, I'm not sure if a compression is the right term, but it's really maxed out here. If I put 14 minus 20 should be -6, and it's 2 dB down. I don't know, it's probably okay. Now I'm going to test the other extreme, and for that I'm going to take the attenuator out again. Okay, so I'm back at the 0 dB. Let's see, I think the lowest is -50. Well, mind you, at those low power levels, sometimes this acts weird because it's very close to the lower end limit for that. So let's see if I turn off, if I switch over to the other channel, then it should be outputting nothing. And then it should drift down to the noise floor around -63 or 65. Yeah, okay, that's good. If I go back, I should be seeing -50 again. Yeah, pretty good. Okay, I think it's fixed. I'm going to do one last test with its internal receivers and see how flat I think it is. And this is probably going to be my final test, and this is at plus 15 dBm, and with, what is this, 1 dB per division, and that ripple, or that non-flatness, is either from the source or the receiver, but as I recall, this is probably within spec. I wonder why it really drops off that sharp at 500. But I'm pretty sure that has nothing to do with the diodes I installed. As a second penultimate final test, you can watch me fumble through a spectrum analyzer menus here to check spectral purity and harmonics. The specs are a very lenient -30 dB below carrier at 10 dBm output power. And at the max, when set to 15 dBm, there's a lot more harmonics, which is to be expected since we're close to the limit of the power amp stage. And for bonus content, I was wondering what the output signal looked like at very low frequencies. So here it is set to 0.5 Hertz. The low frequency amplifier is DC coupled, so it should go pretty low. Let's put that to the test. Now this is 0.125 Hertz. Okay, interesting. The amplitude dropped off a lot, and I'm not sure why that is. Anyway, at this slow of a signal is probably better measured with just a fast DMM. Just for fun, here's HKJ test controller hooked up to my bench DMM. Measuring just DC voltage, and the frequency on the 4195 is set to a period of 16 seconds. I ignore the occasional spikes, that's some GPIB adapter issues. The interesting thing is that the bottom of each cycle is rectified, but only at super low frequencies. Like if I go a bit higher up, it looks a lot better like that. But anyway, that's just wasting time now. The 4195 is repaired now, and thanks for watching.